Hello, my dear friends. I really hope that you are doing great. Welcome to our today's class. It's our 8th lesson on the third topic of Form 3 work, which is called Newton's laws of motion. As usual, let me comment by giving you the quote of the day, which states that old ways won't open new doors. We shall discuss that quote at the end of our class today. So today we are looking at further examples involving Newton's laws of motion, and our first example reads that a trolley of mass 16 kg moving at a speed of 2 meters per second collides head-on with another trolley of mass 4 kg moving from the opposite direction. So if the two trolleys stick together, find their common velocity. So the key point here, the first thing is to identify the type of collision that you are dealing with, and because the bodies are sticking together after collision and they are moving with a common velocity, this one simply means that you are dealing with inelastic collision. And we did say that for inelastic collision, linear momentum is conserved, and therefore the total linear momentum for the system before collision must be equal to the total linear momentum of the system after collision. Also, because the bodies move with a common final velocity, that means v is common, and that's why we can easily factor it out. So let's find the linear momentum, the initial linear momentum for the first trolley. So this was our first trolley A. It had a mass of 16 kg and it was moving at a speed of 2 meters per second. Therefore, its linear momentum shall be given by its mass, which is 16 kg, times its initial velocity of 2 meters per second. Then it collides head-on with another trolley of mass 4 kg moving from the opposite direction at 3 meters per second. So this is our second trolley. We are told that it is moving from the opposite direction. Therefore, it is moving, if our first trolley is moving towards the right-hand direction, then our second trolley B must be moving from towards the left-hand direction. So remember, the word opposite direction simply means that the velocity is negative. Also, they can also use the term moving in the reversed direction, or moving in the backward direction, or moving in the negative direction. So whenever you see the terms like opposite direction, reverse direction, bounces back in the reverse direction or the opposite direction, then simply know that the velocity is negative. So because the body is moving in the opposite direction, or in the backward, or in the negative, or in the reverse direction, that means its initial velocity, which was 3 meters per second, is negative 3 meters per second. Because remember, velocity is a vector quantity, therefore we must consider the aspects of direction. For this particular body, which is 16 kg at a speed of 2 meters per second, here we are taking 2 as positive because it is moving in the forward direction, but this one is moving in the opposite direction. Therefore, if we take the right hand direction as positive, then anybody moving in the opposite direction or in the reverse direction, it must be moving in the negative direction. That's why I have a negative velocity here. Therefore, the initial momentum of our second trolley is its mass 4 kg times its velocity, which will be negative 3 meters per second because of the word opposite direction, or in the reversed direction, or in the backward direction. So the velocity is negative 3. Therefore, its initial momentum is 4 times negative 3. Then the common final momentum, that is the common momentum, the final momentum for the two bodies shall be given by the summation of their masses and their common final velocity v. Therefore, the mass of the first body is 16 kg. Then we add the mass of the second body is 4 kg. Remember, mass is constant everywhere, so it does not change because mass is also a scalar quantity. Therefore, we don't consider the aspects of change in direction. Therefore, the total mass of the system, after they have sticked together, they move towards the right hand direction with a common final velocity. Therefore, the velocity is positive. So 16 plus 4, you will get a total mass of 20. Therefore, 16 by 2, you get 32. Then positive 4 times negative 3, you will get negative 12. Then 16 plus 4, you get 20 multiplied by v, we have 20v. Therefore, 32 plus minus 12, you'll get positive 20, which is equals to 20v. If I make v the subject of the formula, I'll simply divide both sides by 20. Therefore, v is equals to 20 divided by 20, which gives us a velocity of 1 meters per second. So this common velocity, this is just the final velocity at which body A and B move at. That is after they have sticked together, after they have collided. Then, so the key point here is this particular negative here. So whenever you see the word the body is moving in opposite direction, or it is bouncing back, or it is moving in the reversed direction or in the backward direction, then always remember to include a negative on its velocity, just as we have included the negative in this velocity of negative 3 meters per second. So that is the key point there. Then example 2 reads that a car of mass 800 kg. So we just highlight what you have been given. We have the mass 800 kg moving initially at 25. So that is the initial velocity, 25 meters per second. We are required to calculate the force needed to bring the car to rest. Remember, if the car is being brought to rest, that means the final velocity is 0, because we know that at a state of rest, the velocity of a body is 0. Therefore, the final velocity v is 0 meters per second over a distance of 20 meters. Remember, distance in physics or displacement is noted by s, which is 20 meters. So they want us to find the force F. From Newton's second law of motion, we know that force is equals to ma. Therefore, because you already have the mass, we look for a way of finding the acceleration, so that we just take the mass times the acceleration to find the resultant final velocity, or the resultant external force acting on the body. Therefore, based on the values that we have, u, v, and s, if we want to find acceleration A, then this formula will be appropriate. So because we also don't have time, so we use the formula relating v, u, s, and acceleration, because we want to find acceleration. So because we have u, we have v, we have s, and we need acceleration, therefore this formula will be the most appropriate. So for an accelerating body, we know that v squared is equals to u squared plus 2as. So these are just the formulas of linear motion that we derived from our previous classes. Therefore, the final velocity of the body is 0, because the body is moving up to a state of rest. Therefore, 0 squared is equals to initial velocity is 25 squared plus 2 times a, where a is the acceleration, times the distance moved, which is 20 meters. Therefore, 0 squared, you'll just get 0, is equals to 25 squared, you'll get 625, is equals to 2 times 20, you get 40a. Therefore, if I take 40 towards the left hand direction, the 40 will become negative. Therefore, we have negative 40a being equal to 25 squared is equals to 625. If I make a the subject of the formula, I'll simply divide both sides by negative 40, so that a is equals to negative 15.625 meters per second squared is our acceleration. So remember, here we are getting the value of a as negative because the body is decelerating. Because remember, we said that deceleration is simply the negative of acceleration. So we are told that calculate the force needed to bring the car to rest. So if the body is ending its journey at a state of rest, then it must be moving with a reducing velocity. So therefore, in short, the body is decelerating, and that's why we are finding the value of acceleration as a negative. So acceleration is negative 15.625 meters per second squared. Now, once we have acceleration, we can easily compute the force needed. So force is equals to ma from Newton's second law of motion, which is equals to the mass of the car is 800 kg multiplied by the acceleration, which is negative 15.625 meters per second squared. Therefore, 800 times negative 15.625 meters per second squared will get negative 12,500 newtons. So again, the negative simply shows that the force is retarding. The force is bringing the body to a state of rest. Therefore, retarding force will be positive, that is 12,500 newtons. So the word retarding means that the body is decelerating, or the force is applied in the opposite direction. Therefore, the retarding force, or the force being applied in the opposite direction, is equals to 12,500 newtons. So actually the negative is just used to show us the direction, but the final answer will be positive provided you indicate that it is a retarding force or simply it is a force being applied in the negative or in the opposite or in the backward direction. Then example 3 reads that a bullet of mass 20 grams traveling at a velocity of 16 penetrates a sandbag and is brought to rest in 0.05 seconds. So find part A, the depth of penetration in SI units. So remember, the depth in this case is just the displacement or the distance that it moves before it comes to a state of rest. Also remember that at a state of rest means that the final velocity is simply 0. Therefore, the most appropriate formula will be the formula for displacement, which is S is equals to UT plus a half AT squared. But we realize we don't have acceleration, but we have U and V and also the time for the body taken to go to a state of rest. Therefore, because we have U, T, T, but we don't have A, we compute the value of acceleration first. So acceleration is equals change in velocity over time. Therefore, the final velocity, because the body was being brought to rest, that means V, or the final velocity, is 0. We were given the initial velocity as 16 meters per second. Then the time taken for the body to come to a state of rest, T, is 0.05 seconds. Therefore, acceleration is negative 16 divided by 0.05, which gives us negative 320 meters per second squared. Again, we are finding that acceleration is negative, showing that the body is decelerating or the body is retarding. Therefore, if we want displacement will be equal to a ut plus a half at squared. Because we have all the values, we just substitute. Our initial velocity is 16, therefore u is 16. The time taken is 0.05 plus a half multiplied by acceleration is negative 320 multiplied by t squared, which is 0.05 squared. Therefore, if you compute this using your calculator, you will obtain 0.4 meters as the depth or the displacement moved by our bullet before it gets to a state of rest. Then part B, we are asked to find the average retarding force of the sand. So again, we know retarding force from Newton's second law of motion. Force is equals to ma. Therefore, we simply take mass of the body in SI units. So to convert 20 grams into kilogram, we simply divide by 1,000, then multiplied by the acceleration of the body, which was, we had already computed it as negative 320 meters per second squared. Therefore, force will be equal to negative 6.4 Newton. Therefore, again, negative shows that it is a retarding force, or that it is a force which was applied in the opposite direction. Therefore, retarding force is equals to 6.4 Newton as our final answer. Then our fourth example is that a body resting on a horizontal surface is given an initial velocity v so that it slides on a surface for some distance before coming to a stop. The table below shows the distance d moved by the body of various values of v. So we are given that v squared is equals to 20 kd, and where k is a constant for the surface, plot an appropriate graph and use it to determine the value of k. So they have talked of an appropriate graph. So because the graph has to help us to find the value of k, and we are given an equation of v squared is equals to 20 kd, which is an equation in the form of the equation of a straight line, which is usually y is equals to mx plus c from mathematics. Therefore, even when we just observe the values, this is 0.2, 0.4, 0.6, 0.8. This value is increasing uniformly. Then also the distance 0.7, 27, 5, 6. The distance is also increasing. The distance is also increasing uniformly. Therefore, this simply means that if we plot a graph involving any of the values, that is v or d, we are likely to obtain a straight line graph. Then also the equation that we have been given is in form of a straight line graph. Therefore, we just compare the equation v squared is equals to 20 kd in with the equation of a straight line graph, which is usually y is equals to mx plus c. Therefore, for this particular value, we know that m is usually the gradient. Therefore, because we are required to find the value of k, so k is a constant, therefore it cannot be a variable. Therefore, the only varying values are v squared and d. So those are the varying values. So we'll have to plot a graph of y against, that is y against x. So therefore, what is rhyming with our y is v squared. Therefore, we introduce another row that is for v squared by just squaring the values in the row having v. Therefore, 0.20 squared, you'll get 0.04. 0.40 squared, you'll get 0.16. 0.60 squared, you'll obtain 0.36. 0.80 squared, you'll obtain 0.64. 1.00 squared, you'll obtain 1. 1.20 squared, you'll obtain 1.44. Therefore, we add this particular column because the equation that you have been given requires us to plot a graph of what? V squared against d. But for the values of d, we were already given on the table. Therefore, if we plot a graph of v squared, that is meters per second squared, against d, we'll obtain this particular graph here that is based on the values that we have here. Therefore, remember also the values will give you some points which are outside the line. Therefore, because it is an experiment, we don't expect all the values to be in the straight line. Therefore, we draw a line of best fit. Then again, I've done here times 10 power negative 10 for easy plotting. So you also remember to include times 10 power negative 10 on your workings. Therefore, also we have times 10 power negative 2, that is the distance. So this will help us to conveniently plot our graph, so that when we are plotting the graph, for example, this case, we'll consider the value of d having 0.7. Here we'll consider 2.7. Here we'll consider 5.6. That is, if we consider times 10 power negative 2. It helps us to move the number of decimal points. Therefore, this is our expected graph. So you look at any 2 points that are within that particular line, then you use them to calculate your gradient. Because from this particular equation, you can clearly see that the gradient m shall be equal to 20k. So if we find the gradient and we equate it to 20k, it will help us to compute the value of k. Therefore, the gradient from our graph will be changing the value of y divided by change in x. So, but on the y-axis we have v squared. Therefore, gradient is equals to change in v squared divided by change of values in the x-axis, which is d. Therefore, the gradient is change in v squared over change in d. If I take two typical points, for example, this point and this point, I know I want to use these 2 points to calculate the gradient. Therefore, the gradient is change in v. So this point, the value of v or the y is 10. Then the value of y for this other point is 1.6. Therefore, we have 10 minus 1.6, giving us our change in v squared. Then, of course, v, we were to multiply times 10 power negative 1. So times 10 power negative 1 divided by change of values in the d or in the x-axis. So we talk of the first point is 17. Then we subtract from the value of x, which is 2.7, or the value of d. Then again, horizontally, we were to multiply times 10 power negative 2. Again, remember the units will also cancel out, so that we are taking meter squared per second squared, which were the units for v. Then we divide by the units for d, which is meters. So one of the meters will cancel with one of the meters, so that we remain with meters per second squared. So you compute this using your calculator, you'll obtain 5.874 meters per second squared. So this one I've just expressed it to, that is 4 significant figures. Therefore, from this equation, m, which is equals to gradient, is equals to 20k. That is just by direct comparison. Remember here, we don't have plus c. This one means that the value of c is 0. And that's why our graph is starting from 0.00, or yeah, it is starting from 0.00, showing that the value of the y-intercept is 0, or the value of v squared intercept is 0. And you can also see from our graph that the value of v squared intercept is 0, because the graph is starting from 0.00. So this would be plus 0, but there is no need. Maybe you can just add it for uniformity. Therefore, m is equals to 20k, and we know that m is equals to 20k, which is equals to the gradient. That is from mathematics. M usually represents the gradient of your graph. C is usually the value of the y intercept. Therefore, if I pick this equation alone, 20k is equals to the gradient, and I make k the subject of the formula because I'm asked to find the value of k, so k will be equal to gradient divided by 20. But we already have the value of the gradient as 5.874 meters per second squared. Therefore, k is equals to the gradient, which is 5.874 meters per second squared, divided by 20. So this gives us 0.2937 meters per second squared as our value of k. So the most important thing here is to know how to interpret the graph. And most graphs in physics will be straight line graphs. Not all graphs, but most graphs. So whenever you have you are plotting a graph that gives you a straight line graph, just compare it with the equation of a straight line graph and use the gradient to find the unknown values or the y-intercept as specified by the question. So lastly, I have some exercise here that I recommend you should try at your own free time to gauge whether you've understood. Thank you very much for accompanying me until the end of this particular lesson. We are at the end of the lesson, but we need to discuss the quote of the day. The quote of the day stated that old ways won't open new doors. So the quote is just encouraging us to explore different ways and different methods of handling different issues in our lives. Yeah, if you try method 1 and maybe it failed, it is a high time that you try maybe method B or method C or a different variety of methods, provided you get your desired results. And one of the scientists, physicist, who was a great physicist in physics called Albert Einstein, once said that we cannot solve our problems with the same thinking we used when we created those particular problems. And lastly, remember that insanity is doing the same thing over and over, yet expecting different results. Yeah, if you've been trying something for a very long period of time, it's a high time you try something else, or you try doing the same thing but with different methods. So we need to be flexible in our workings. Don't just be too rigid when things are not working out. You can always try out new method. You can always try out new ways of approaching the same problem. So thank you very much for accompanying me until the end of this lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get a notification. Also, if you know any student or anyone that you honestly think could benefit from this content, kindly do me an act of kindness and refer them to Kind Tuition Academy. Thank you very much. Until next time. This is Kind Tuition Academy.